Hi, all. This is the Goblinos Cloud Podcast, brought to you by Ethan Michalak, Felix Vo, and EJ Lucero. We're going to talk to you guys today about the future of cloud technology and the current state of cloud. We'd also like to give a special thanks to Barbara Bro, our professor and the sponsor of this project. The podcast itinerary goes as follows. We're going to talk about the cloud and organizations and how organizations currently use the cloud, the future of cloud design and architecture, the future of cloud services and applications, the future of cloud security, and cloud computing predictions. Now, corporations are moving to the cloud at an increased rate. If we look at this graph titled Organization Data, in the year 2022, 60% of corporate data across many different corporations are stored in the cloud over time. Additionally, in the cloud stats, we have 94% of enterprises use the cloud in some capacity. Over 50% of enterprise infrastructure is cloud-based, and 92% of businesses have a multi-cloud strategy in place or in progress. All of these stats are saying, the cloud is not going away anytime soon. And organizations that are not using the cloud already should seriously think over their plan and strategy and how maybe they can utilize the cloud to increase their corporate presence. Additionally, with end users and regular people, they also have increased cloud usage. 71% of people use cloud services to store their photos, and this could be things like iCloud, Google Photos, or even Google Drive. 48% of tech companies invest in cloud computing technology innovations, which directly affects end users and regular people. And 34.7 million Americans have the option to work remotely. This can be things like Zoom or Discord or Microsoft Teams. This podcast itself is being recorded on a cloud service, which is using Discord to facilitate the call.
Hello, hi, my name is Felix, and I'll be going over the future of cloud designing and architecture. So, the future of cloud designing, oh shoot, wrong button. Okay, so the future of cloud design is exciting and constantly evolving. With the growing adoption of cloud computing across industries, there's a need for innovative and efficient cloud design solutions. So, for starters, cloud design refers to a network design model that leverages cloud computing, service architecture, Web 2.0, and semantic web technologies. These they would need these characteristics to support cloud-based engineering, design services, and distributed collaborative environments. All right. So for proper cloud design is necessary in order for it to work properly and be the most effective it can be. When designing a cloud, there are several things we need to take into account in having order and to have a proper running cloud platform. The cloud is on the internet, and that means that cloud networks can be isolated with only VPN connections to internal networks, but it is very easy to expose data publicly. As the rise of cloud goes up, so does the need for security. It's important to protect the data that these cloud services are trusted with. Sensitive information is always endangered for being breached or stolen, often when it comes to cloud services. Something to also consider that is part of the design of network designs is the critical that the data highway between system and users. The network design is very like overlooked and should be also like highly considered when it comes to like the cloud. So for other words, cloud networks need to be planned using IP spaces that do not conflict with existing networks and should be open to growth for future plans. The analysts for the team should also consider where these resources will be placed as regions and other communications will be routed. And stability and fault tolerance. So for stability and fault tolerance would be Next thing that is needed, cloud providers should expect and know how to handle events that come up out of the blue. For example, it is known that the cloud providers often go down. When these type of things occur, you need to have a fault tolerance. Each cloud provides for designing fault tolerance into applications and infrastructures. But it's important that the correct components must be designed around the correct usage, um, acceptable costs, and whether or not their use is supported for the situation. If failure is not expected or planned, so it's important that the failure is like planned so that the disruptions can occur and money can be lost. So it's always good to like expect something like bad to happen, like not a natural like disaster, right? So moving on, serverless computing, right? Serverless computing is also something that is growing in trend in the cloud design world. It's the concept where applications are uh, being curated using cloud functions without the need for dedicated servers. And one of the reasons why it's like very popular or very like effective or used often is uh because there's methods that reduce costs, increases scalability, and improves efficiency. So moving on to edge computing. Edge computing is a distributed computing paradigm that brings computation and data storage closer to the location where it is needed. This is becoming increasingly important as devices connect to the internet. The volume of data generated by these devices continues to increase. In other words, as more devices become connected to the Internet of Things, there will be a bigger demand in edge computing. Something people are not aware of is the thing is Internet of Things. So they don't exactly know what it is or how it works. The Internet of Things is a network of interconnected physical devices, vehicles, buildings, and other objects embedded with sensors, software, network connectivity, allowing them to collect and exchange data with other devices and systems over the internet. See, the type of devices can range from complex machines such as appliances, our smart watches, etc. Like IoT devices collect data from the surroundings and send it to a centralized platform or a cloud-based system where it can be analyzed, processed, and used to make decisions and automate tasks. IoT technology has numerous applications, such as smart homes, health monitoring, traffic management, energy efficiency, industrial automation, and agriculture. It has the potential to transform industries, improve efficiency, and enhance quality of life for people around the world. But there's like, although like the IoT sounds, oh shit, I went the wrong way. Sorry. Although like IoT sounds very good, there are some downsides to it, unfortunately, right? See, because like as a rise of technology, of the IoT technology, it raised concerns around privacy, security, and the ethical use of data. As the use of IoT technology continues to grow, it is important to consider the potential risk and take the measures to mitigate them. Some of the risks would be things like privacy, security risks, malfunction and safety risk, legal and compliance risk, interoperability, fudge is a big word, sorry, interoperability and standardization risk, and ethical social risk. Next thing I want to talk about is quantum networking. So what's quantum networking? Quantum networking refers to the use of quantum technologies to create secure communications channel between two or more parties. Unlike classical networking, where information is encoded and transmitted using classical bits, quantum networking uses quantum bits to encode information. The main advantage of quantum networking is the ability to create unbreakable encryption methods based on the principle of quantum mechanics. One of the most promising applications of quantum networking is quantum key distribution, a protocol that uses the properties of quantum entanglement to create secure encryption keys. QKD is considered to be unconditionally secure because any attempt to intercept or measure the transmitted qubits will alter the state, alerting the sender and receiver to the intrusion. Another potential application of quantum networking is quantum teleportation, a protocol that allows the transfer of quantum information from one location to another without physically moving the qubits. This has to be this has the potential to enable faster, movie, or more efficient communication over long distances. However, quantum networking is still in its early stages of development, and several challenges need to be addressed, such as the vulnerability of qubits to environmental disturbances and the difficulty of scaling quantum networks. Despite these challenges, the potential of benefits in networking are significant, and then it is an area of active research development.
Um, Hello, my name is Hernani Lucero. I'll be talking about future of cloud services and applications. Today I'll be discussing telemedicine and remote surgery, augmented and extended reality, decentralized cloud services, autonomous systems, and digital twin capability. Telemedicine and remote surgeries are two areas that are already seeing significant growth and development, and cloud services are playing a crucial role in enabling this. With the help of cloud services, doctors and surgeons can access medical records, imaging data, and other critical information from anywhere in the world, making it easier to collaborate with colleagues and provide remote consultations and surgeries. This has become even more important in the wake of the COVID-19 pandemic and healthcare providers have had to adapt to new ways of delivering care. Augmented and extended reality are becoming increasingly popular in industries like gaming and entertainment, but they also have practical applications in fields like education and healthcare. With the help of cloud services, companies can create immersive experiences that allow users to interact with digital objects in real-world environments. This could include things like virtual training simulations for medical students or remote assistance for technicians working in the field. Decentralized cloud services refer to cloud-based systems that are distributed across multiple locations. Rather than being centralized in one data center, this can provide a number of benefits such as increased security, better reliability, and faster performance. By using decentralized cloud services, companies can ensure that their data is more secure and that their applications are more reliable even in the event of network outage or disruption. Autonomous systems such as self-driving cars and drones require vast amounts of data processing and storage in order to operate effectively. Cloud services can provide the infrastructure necessary to support the systems, allowing the companies to process and analyze data in real time and make more informed decisions. Additionally, by using cloud services, companies can ensure that their autonomous systems are always connected to the internet, enabling them to receive real-time updates and respond to changing conditions more effectively. Digital twin capability refers to the ability to create a digital replica of a physical object or system, such as a factory or a piece of equipment. This can be useful in a variety of industries, as it allows companies to simulate and test different scenarios without risking damage to physical object. Cloud services can provide the computing power necessary to create and analyze these digital twins, making it easier for companies to optimize their operation and reduce downtime.
It's great to be here and to talk about the future of cloud security and the current state of it. Organizations, as they rapidly move to the cloud, must consider vulnerabilities and security issues that come as a result of it. Organizations seeking to move to the cloud often enter a partnership with the cloud provider. The cloud provider like AWS, Google Cloud, or Azure will often offer to take care of some level of security, whether it's just on the services that they offer or on the infrastructure itself. However, organizations and corporations often take a large bulk of this security, and how they handle it will be up to them mostly. There are also no lack of threats in cloud security. In the year 2022 alone, ransomware continued to increase almost 13%, and this trend will likely not fall anytime soon. There is also an increase by 43% of cryptojacking and an 87% increase in Internet of Things malware. And Internet of Things malware is especially relevant to organizations and corporations seeking to move to the cloud, because if they offer any type of product like that, they're most likely going to do a large portion of the Internet of Things offerings in the cloud, whether it's data collection or data processing. Hackers also stole a record $3.8 billion during 2022, and mobile banking Trojans doubled in volume. These statistics are not only scary, but extremely relevant for corporations and organizations seeking to use these next level computing tools. Additionally, as a proof of concept, I went on Showdown.io, or used the service Showdown, to look at how many computers using in a small chunk of AWS had port 3389 open, or the remote desktop protocol. And it's not surprising that just in this small chunk of AWS, there's 357 computers actively uh, allowing 3389 connections. Now, 3389 is responsible again for the remote desktop protocol. And this is just a small proof of concept indicating that the attackers and the threat actors have no shortage of scope in their attacks. Additionally, things like serverless computing and other new cloud service offerings bring in a new swarm of vulnerabilities. Now, serverless computing is offered by Azure and AWS and many other cloud providers, and is a way for organizations and corporations to run code without any setup at all. It is not actually serverless, but from the point of view of the corporation or organization, it is. Now, attackers may find joy in trying to hack these services because it is a new style of computing, and there are vulnerabilities organizations don't understand yet. To fix these issues, I propose some solutions that organizations and corporations can use to drastically reduce the chances of them having a breach. The first solution I propose is zero trust, which is a new type of security model and philosophy. Then some cloud offerings, such as cloud access security brokers, cloud workload protection platforms, cloud security posture management. I also think organizations should take advantage of crowdsourced security, which greatly benefits cloud security in many ways. And I think organizations should also understand and use security as a service in the future. Now, zero trust is a developing security model and also a philosophy. It centers around the saying, never trust, always verify, because people seeking to implement zero trust should understand and always verify connections and personnel that are taking place in their network. Zero trust developing security models often revolve around things like multi-factor authentication, and authorization on as many segments of the network as possible, and segmentation and inspection on network traffic everywhere in the network. Now, it is still developing and is not fully ready to be used by corporations, organizations, but there are many emerging products which take care of zero trust as a whole or parts of it. These are some cloud solutions that are already offered that take care of a lot of security issues that organizations may face. For example, the cloud access security brokers, which is offered through AWS and Azure and the like, offer enforcement of security policy monitoring of user activities, data flows, and even application usage. So if there is some type of anonymous user activity or a user is performing actions they wouldn't normally otherwise perform, the Cloud Access Security Broker would flag this. It also offers detection of malware, which includes ransomware, adware, cryptojacking, any type of malicious software that organizations would not like to deal with. It also offers cloud workload protection platforms, which allow organizations to truly understand their environments. This includes understanding, the running inventory of it. How many virtual machines and computers does my organization currently have in the cloud? It also offers deeper insight into those assets, such as are there any running vulnerabilities on my virtual machines, and what are their configurations. Cloud workload protection platforms often also use AI to respond to any threats that are identified. It allows for easy compliance and reporting in the case of some discrepancy. Cloud providers also offer cloud security posture management, which allows for automated risk identification and prioritization. So if there is some type of big vulnerability that applies to a lot of new systems, it will automatically prioritize that for a team of analysts. It offers compliance monitoring and integration with cloud access security brokers and cloud workload protection platforms. So it can often tie everything together. Now, moving on to crowdsourced security. What I mean by this is the use of applied threat intelligence. There are things like Yara and Sigma roles, which allows for easy identification of malicious files and malicious attack patterns. Now, an organization that I think really embodies the use of applied threat intelligence is CrowdSec, and we'll be talking about them a little bit more later. Yara rules and Sigma rules look like this. On the right-hand side in the top, we have an example of a Yara rule, which is set to detect a SMB worm. And if you look at the strings portion of it, it has unique strings or unique bytes that uniquely identify that SMB worm. And by loading thousands of these Yara rules, your organization would be protected against a large portion of malware. Moving on to Sigma rules in the bottom right, here's an example of a Sigma rule that can detect a password dump behavior. By looking at a certain event ID by Windows logs and sysmon, it looks for that event ID and then looks for a target file name that is created as a result. And this can uniquely identify a certain type of password dump and not just a password dump in general. Now, as I mentioned CrowdSec earlier, as a good inspiration for organizations and corporations seeking to either implement their solution or implement applied threat intelligence, CrowdSec has a model that allows for organizations to download and install agents on their servers or other externally facing devices. And these agents will look at any logs that are relevant, such as an Apache web server access log, SSH authentication logs, or any other logs. It then uploads these logs to a centralized repository of all logs that CrowdSec encounters on all their agents in the cloud. And they're able to push back decisions for what should happen according to what log entry. For example, if there was a long string of failed authentications from a certain IP, CrowdSec would push back a block signal, which means that all CrowdSec agents that the organization or corporation has would be able to block that IP instantly. It also allows for configuration of alerts. So if anything did happen, such as a block IP, it could be aggregated into a SIEM. What is interesting about the CrowdSec model is how any organization that takes part with CrowdSec agents will be able to automatically share and apply this data without even knowing it with other corporations and organizations, because they have the centralized CrowdSec API and repository. Security as a service, I think, is another asset of security that organizations should take advantage of in the future with cloud. There are organizations like Huntress and Sentinel-1, which offer EDR and XDR products, which offer next level endpoint protection, but come as a service package or as a host package. And this allows for easy application to ephemeral services and ephemeral infrastructure in the cloud. They also offer on site SOC and threat hunting. So if you opt in for a greater package, you could offload a lot of your risk and a lot of your security to these organizations who are willing to do it, for a fee. I think organizations and corporations would also greatly benefit from opting in some type of bug bounty program. Bug bounty is where freelance hackers can sign up to, uh, do vulnerability tests or do penetration tests on your organization externally, and will report these vulnerabilities for a certain fee. Maybe there's some type of RCE or LFI vulnerability that you didn't previously know about. Then you would pay one of these hackers $2,000 for the proof of concept. And this basically allows 24/7 pen testing from around the nation and around the world for that matter. Now, CISOs and cybersecurity personnel should really consider all these different facets of cloud security, as many of these solutions may not fit their organization, as a lot of these are not one size fits all. But by combining one or even two of these, they can greatly reduce the risk of being hacked or taken advantage of by malicious entities. Now I'm going to talk about the future of cloud computing. Now I'm going to talk to you guys about cloud computing as well, or rather the future of cloud computing. There are four areas which I think will dramatically change the cloud computing landscape in the future. These four areas are edge computing, serverless computing, AI driven cloud computing, and infrastructure as code. Now, edge computing is a simple practice of organizing servers next to where data is being generated. A simple demonstration of this could be if I am generating my data in California and my servers are located in Washington, D.C. or Florida, my data has to travel the entire length of the country to actually be processed, right? And if I'm generating a massive amount of data in the terabytes, this also has to go across the entire country. But if I place my servers in California, where I currently am, it would reduce latency dramatically, right? And this is the main benefit of edge computing. It also allows for greater security because my data has to travel through less devices to reach the destination. It also, the main use of cloud computing is with IoT devices or Internet of Things devices. Internet of Things involves putting computers and sending data from things that traditionally wouldn't be there. Things like cars, fridges, and even thermostats all generate data and send to servers across the globe. And by placing these edge nodes or edge servers next to where the IoT devices are, it allows for, again, reduced latency and greater security. Another facet of the future, I think, in computing will be serverless computing. Now, I mentioned serverless computing a little bit before in the cloud security, but not to the length of which we're going to explore right now. Serverless computing is the practice of allowing organizations and corporations to run code without any configuration whatsoever. They simply put their code into AWS, Azure, or other cloud providers, and the code will run automatically without any infrastructure provisioning or anything like that. This allows organizations to reap many benefits, such as cost efficiency, whereas then they're only paying for the compute time they're actually using, not the entire infrastructure itself. It also allows for better scaling and the deployment or easy deployment of microservices. Microservices is a new type of computer architecture where significant portions, or really all portions of the entire product, are broken into tiny pieces. And all of these pieces can be scaled independently if there are any bottlenecks. AI-driven computing, I think, will also be a major tenet of cloud computing in the future. And this is due to recent developments in AI. If we look at things like ChatGPT and even GPT-4 with its reflection model, it is only a matter of time before AI makes its way into cloud computing. I think where AI will benefit organizations greatly is in infrastructure management. I think if an AI could manage infrastructure, it can increase the efficiency and the costs of infrastructure overall. It would also allow for the AI to respond to or identify any threats, right? It would be able to be adaptive in that environment. So I think it'll be a massive tenet in the future. Infrastructure as code, while not necessarily a new thing, I think will take much more of a role in the future as time goes on. Infrastructure as code is simply where your code is stored as configuration files, or your infrastructure is stored as basically code, where it can be audited and looked at from a human point of view without having to investigate a virtual machine. The tools responsible for infrastructure as code are Ansible, Packer, and Terraform. Terraform is the tool that actually does the provisioning. Terraform will automatically talk to cloud providers such as AWS or Google Cloud and ask for a certain type of instance that you specify. Packer is the configuration tool that will automatically configure things after Terraform has provisioned them. And Ansible is a distributed configuration tool that occurs through SSH and FTP. This is an example of some infrastructure as code. And it's using Packer and Terraform in this example. We see under the builder section that it's specifying where the actual instance is going to take place, right? It's an Amazon instance. And then in the bottom with provisioners, it's the actual commands that the Packer is going to run on the server. So this code would be capable of spinning up an AWS instance and then automatically configuring it to be a web server. Obviously, this is a contrived, easy example, but an organization or corporation with enough resources would be able to move a significant amount of their infrastructure to infrastructure as code. And the main benefits of this are, obviously, you can deploy your entire infrastructure or a large chunk of it with a click of a button or the run of a single command. It also allows corporations and development teams to audit their infrastructure over time. Whereas before, it was incredibly difficult to do so because everything would be stored as virtual machines or something similar to virtual machines, which meant that you would have to have custom tools that would take inventory or some type of analysis of the virtual machines themselves. And typically, virtual machines are also prone to virtual machine sprawl, which means that they would have little changes over time that you would not be able to understand. However, with infrastructure as code, because everything is built out every time, it will never change the environment. It will always be exactly the same as it was before. With all these tools at their disposal, organizations and corporations have so many options to them to dramatically change the way that they deploy infrastructure and use cloud computing in general. They have so many tools that would be deemed impossible in the past, but are now available and often come with many guides and many tutorials. So I think the future of cloud computing will revolve around edge computing, serverless computing, AI-driven models, and infrastructure as code. Alrighty, so that's our podcast on cloud computing and the future of everything that cloud has to offer. Again, it was by Ethan Michalak, myself, Felix Vo, and EJ Lucerno. Felix, would you like to say anything?
Yeah, I would just like to say, thank you for Professor Bro for having us here and sponsoring this podcast, and also for our roommates for putting on the effort, um, working together, and just having a good communication between our group. Thank you.
Thank you. All right, we'll see you next time.